Now coming to the last numerical of the day, solution of 3 electrolytic solution cells are ZnSO4, AgNO3 and CuSO4 are connected in series. Okay, as you can see that there are 3 electrolytic solutions which are connected together in series. That means which law is applied here? The law that must be applied here is second law of electrolysis. Faraday's second law of electrolysis. So now let's proceed with the question. Of the cells A, B, C respectively, after passing a steady current of 1.5 ampere, 1.45 grams silver was found deposited at the cathode of cell B. How much time did the current flow? What amount of zinc and copper are deposited? Now, first of all, the first thing that you need to note down that what are the given things in the question. In the question, you have 3 electrolytic cells connected together in series and you have the mass of one atom deposited at cathode and the current that was passed is 1.5 ampere. You need to find out the time that was required to deposit this much mass of silver and also the amount of zinc and copper that are deposited at respective electrode. So we will first deal with silver only since we have the maximum information regarding silver. As you can see here, the reaction for the conversion of Ag plus to Ag is mentioned here because in case of AgNO3, the charge over Ag is plus 1. So it will gain 1 Faraday it will gain 1 mole of electron or 1 Faraday of electron to get converted into silver. And the atomic mass of silver is 108 gram. Don't worry about the atomic masses, children. It will be given to you in the question in your board examination. So, to deposit 108 gram of silver, this much charge is required. That is 96500 coulomb charge will be required. Now, to deposit 1.45 gram of silver, how much charge will be needed? This is the question. Okay, so again recall the same formula, that is the weight of any substance deposited is equal to the atomic mass into charge upon n factor into Faraday. Now in this particular case you need to find out the value of Q. So the formula will get modified as W into N into F upon atomic mass. Okay. So this will be the formula and by substituting the values you can reach to the value of Q. So this is what is done here. You can see that 96500 is being substituted here into N, which is 1, and into W, that is 1.45 upon atomic mass, which you can use 108 also or 107 also, and the final value of the charge will be equal to 1295.43 according to this calculation. When you'll use 96500 in place of 96487, there can be slight variation in the answer, and in case of 108 or 107, which value to be used depends upon what value is given in the question to you. Okay, so this much is calculation is done. Now moving on to the other given data. The other given data are the value of current is given to you, that is this 1.5 ampere. Now you have the formula Q equals to IT with you. Since you have to find out the time, obviously the time will be equals to Q by I. You have the value of Q from the above calculation and the I is given in the question. So the time will come out to be 14.40 minute. Okay, so I hope this much part is clear. Now the another part of the question is to find out the amount or the mass of zinc and copper that is being deposited. Again, you will be using the same formula, that is W is equal to atomic mass into charge upon NF. Now to find out the value of N, again you will be needing to write down the ionic equation. right? You can see here the ionic equations are mentioned. Cu2 plus is getting converted into Cu by gaining 2 moles of electrons. So in this case, the value of N is equal to 2 and the atomic mass of copper is 63.5 gram. So by substituting the values in the formula that I told you before, you will get the answer as 0.426 gram of copper. Similarly, in case of zinc, zinc is gaining 2 moles of electron to get converted into Zn. The zinc is present in the form of ZnSO4. Obviously, the oxidation state of zinc is Zn2 plus, which is a constant. Zinc is always present in the form of Zn2 plus, whereas copper can vary because it exhibits two valencies, Cu2 plus and Cu1 plus. So for this, you need to find out the oxidation state with the help of the molecular formula of the compound provided to you. Now in this case, again 2 moles of electrons are involved, so the answer will be with respect to the value of N will be equal to 2 again in this case also, and the atomic mass of zinc is equal to 65.4 gram. So again, substituting the value in the formula that I mentioned earlier in the same session, you will get the answer of for this calculation as 0.439 gram of zinc. So I hope the numericals discussed today is clear to you. Children, practice these numericals and then try to practice some more numericals from the book, from the reference book, and if you need some other questions, you may contact me for the other numericals. So in today's session, we discussed about the calculation part in detail with respect to the numericals. I hope the session is clear to you. Thank you, children. Have a nice day.